Once again, welcome back to fourth experiment of CRD. This is also basically in a batch reactor. The aim of this reactor experiment is to calculate activation energy of saponification reaction in batch reactors. So earlier in first experiment, what we performed holds true for this also. And actually in this experiment, similar reactions at different temperatures we have to perform. I think you must be remembering what activation energy is. So it is energy required to activate molecule so that they get reacted and can be converted into product. So this is minimum energy. Here in previous experiment it was isothermal reaction in first experiment. So the room temperature was considered as temperature of reference. Here we will increase the temperature by, let us consider, by 7 to 8 degree or 10 degree Celsius and move on up to 60 degree Celsius, so that we are having about 4 to 5 different temperatures, and that can be taken for calculation of activation energy. Further experimental procedure will be explained by Sumit Patil, which is my master student.
The aim of our fourth experiment is to calculate the activation energy required for the saponification reaction. As we have already studied the saponification reaction, everything is same, but the only difference is we are carrying out the reaction at different temperature, because in this case we are needing to find out the activation energy required for the saponification reaction. We have to calculate the saponification reaction for at different temperature. We will carry out the reaction. We have taken the 0.1 normal NaOH solution and 0.1 normal ethyl acid solution and poured this both solution in this batch reactor and set the temperature at certain temperature, say for example 50 degrees Celsius, and we immediately take 10 ml of sample solution and titrate this sample against the 0.02 normal of HCl solution, and doing this procedure for again 2 minutes after, and such things will be continued for 10 minutes or 20 minutes. So we will have a 10 to 15 readings at one temperature. Now in order to stop this reaction, we will add some amount of water. Then the reaction will be stopped. Again we will increase the temperature and we will do the same procedure for the next temperature, and in the third step we will again increase the temperature by certain amount, or say 5 degree or 10 degree as per your need. Then this procedure is repeated for 5 to 4 or 4 to 5 temperatures, and we will find out the value of reaction rate constant, and the reaction rate constant is related to the activation energy by a very well known Arrhenius equation, which is given by K equals A e to the power minus E by RT, where E is the activation energy and activation energy is nothing but the minimum amount of energy required to begin the reaction. And using all those readings, we can easily find out the value of K. Thank you.